Alrighty, so here's another homework problem. In this problem, we have a regular triangular pyramid. I've drawn it here, or as best as I could, where BC, which is the length of this edge, base edge right here, is 6, and VA, which is this lateral edge here, VA, is 4. And this is a two-part problem. I guess really it's a four-part problem. We want to find the length AM and AO, and then we want to find H and L. So let's first figure out what these things are. So AM is this red length shown right here. Hopefully you see that. And notice here that it is perpendicular. AM is perpendicular to BC. And then AO is a portion of that. So where is O? Well, so O is from the vertex of this pyramid down to the base of the pyramid. And we want to take a good look at what we know about this pyramid. Since we know that it is a regular triangular pyramid, well, that tells us two things. One, that this vertex is directly over the center, and so that we can make a note of that. That O is the center of the base. And also, because it's a regular pyramid, we know that that base is an equilateral triangle. Right? So I've kind of marked that off already, that if BC is 6, then AB is also 6, and so is AC. We actually don't need to know about anything else in the pyramid to find AM and AO. So I'm going to draw a picture of this base right here. And so if this will be A, this will be B, and here's C. And we know that the base is 6. Since we know that AM, which goes down right here, because it's perpendicular and we know it's an equilateral triangle, that would also tell us that it bisects this side right there. Since again it's an equilateral triangle, all three sides of that triangle are 6 as well. And this has come up in several videos at this point, that this triangle right here that I'm going to highlight in red, that's already a 30, 60, 90 triangle. And so if that, oh, right there's M, then AM, it's the long leg of 30, 60, 90 triangle. So we already know that that should be the hypotenuse, which is 6, times root 3 over 2. And this has come up a number of times at this point. And if I shorten that, or simplify that, that'll be just 3 root 3. So that's AM right there. The last part, AO, so O is right here, and this one is a little bit tricky. If there's O, and maybe I should zoom in right here. How can we figure out AO? Well, one way we could figure out AO is if we could figure out OM and then subtract OM from the entire AM. Well, how could we do that? One way to do that would be to figure out, and using a little bit of right triangle trig, this new triangle. And I'm going to draw this one in blue. Figure out the side lengths of this triangle. That is another 30, 60, 90 triangle. And we've seen this one before as well. And so since this bottom leg is bisected, let me draw this triangle a little bit bigger here. So right here, this is O, this is M down here, and this is B. Sorry. This has to be 3. And so this is again a 30, 60, 90. This would be 30. This is not the scale. And this would be 60. And I'm going to call this side the hypotenuse. So I'm going to call it C. So I always have trouble kind of building the connections between all three sides together, but I do know the connections between the legs and the hypotenuse. So I do know, again, this is based off this actually, that the hypotenuse times root 3 over 2 equals the long leg. So in this case, the long leg is the 3. So if I actually want to find C, that would tell us, let's say I need to multiply both sides by 2 and then divide by root 3. So that would tell me that C is equal to 2 times 3, which would be 6, divided by the square root of 3. Okay, so that's the hypotenuse, but that's not actually what I need. I want OM, this side right here. So if I'll just call it question mark. Well, that'll be OM. We'll call it OM. OM then would just be equal to, well, the entire AM, oh, sorry, I'm jumping ahead of myself. This is now the short leg of a 30, 60, 90 triangle, and the short leg of a 30, 60, 90 is always half the hypotenuse. And so if the hypotenuse here is 6 over root 3, then half of that would simply be 3 divided by root 3. So now I can put those two together and say that AO is equal to AM minus OM, which would be 3 root 3 minus 3 over root 3. This is a little hard to do as is, so I'm going to actually want to simplify or rationalize OM here. So how would I do that? Well, I need to get rid of that root 3 in the denominator, so I'll multiply by root 3 divided by root 3. So again, this is really just a big 1, so that's why it's okay to do this. 3 root 3 minus, let's see, what will this be now? This will be, well, actually this will be 3 root 3 again on top, and on the bottom it'll be, oops, divided by 3, because again, the square root times the square root just undoes the square root. And if I do this, well, hey, wait a minute, 3 divided by 3, that's just 1. And so I really have 3 root 3 take away 1 root 3, which means that AO is equal to 2 root 3s. Okay. So that is the first part of this problem. Hopefully that made some sense. Again, so the 30, 60, 90 triangle has come up several times at this point. So that's definitely a triangle that you want to be familiar with, because it definitely speeds a lot up. Okay, so now we want to find H and L. So let's just be clear on what H and L are. Excuse me, I need to sneeze real quick. Okay, so H, again, is the height of the pyramid. And since, again, this is a regular triangular pyramid, that height drawn in here is directly over the center of the triangle, which is O. L is the slant height. Again, that would be the height of this face right here. Now, here's the thing. Because this is a regular triangular pyramid, we also know that all the lateral faces, again, all these triangles, are congruent. And so if VA is 4, we also know that VB is 4, and so is VC. Oops, sorry, VC. Again, because it's a regular triangular pyramid. So let's use that fact here. Well, we can actually see a little bit of what's going on. Is that the red triangle that you see right here in the drawing, I'm going to pull that out over here. So, or I guess I'm drawing it in pink. Here's H, here's L, that's pink there, and this is OM right here. This length right here is OM, which we actually know. OM, which is right here, 3 divided by root 3. Or when we simplified it, let's actually do this. When we simplified it, it was actually just the square root of 3. Okay. Well, I actually don't know H and or L, and so I'm kind of I kind of run into a wall here. But if I could find H or L, then I could find the other one. So let's see. What else could I see in the original picture that builds a connection to H or L using stuff that I know? Well, take a look at what we did in the last problem. We found the length BM, which was 3. I'm going to highlight a triangle right here, and it's a little hard to see. It's not very pretty too. But if you see right here, I'm drawing a right triangle right here between, here, I'll do this, VMB. And I'll draw that triangle right here. So let's see, those two are in black, and then L, which is right here in red, V, M, and B. We already know that BM is 3. What else do we know about this triangle? Is that from the setup here, again, because it was a regular triangular pyramid, that we know that VB is 4. And now we can get L, because this, again, is a right triangle from the original setup. So we can use Pythagorean theorem. And so we know that 4 squared is equal to 3 squared plus L squared. Let's see, this will be 16 and then 9, so that'll be 7 equals L squared, leaving us with L equals the square root of 7. Not super pretty, but it is an answer right there. And then now we could use this and this pink triangle to find H. And so H, well, I'll draw the triangle again. I now have square root of 3, square root of 7, leaving us to say H squared plus root 3 squared equals root 7 squared. H squared has to be equal to, oh sorry, let's see, 3 squared, or the square root of 3 squared is just 3, and the square root of 7 squared is just 7. So that would mean that H squared has to equal 4, meaning that the height of this pyramid is actually equal to 2. Hopefully that made some sense. And again, this is all about, like most of these problems, all about using what we know from past triangles, 30, 60, 90 triangles specifically, and putting those all together. And of course, Pythagorean theorem almost always comes out somewhere.